Section 6.3, we're dealing with intersections of straight lines and circles. And I'd like to just go on a little tangent before we get to talking about this section specifically and remind you of a couple of things that we already know. First of all, if you have a quadratic, it cannot touch the x-axis, so a quadratic function can have no roots. A quadratic can hit the x-axis in two places, and then the quadratic function has two roots, or the quadratic can hit the x-axis just as a tangent to the curve at the turning point, and you get a quadratic function with one root. So you can have equations with no solutions, two solutions, or one solution, and this is, if we take those equations and turn them into functions and draw them on graphs, and this is what they look like. So we know that fact. The second thing we know, and if I'm the person teaching you, then hopefully this has been hammered thoroughly into your head by this point, but if you've got two equations which are linking y and x, and you get equation number 1 and equation number 2, and you're trying to solve them simultaneously, you can think about that as look at the functions and look at where the graphs cross. So draw a graph of y in terms of x, and it doesn't matter what shape the graphs are, the point where those graphs cross is going to be the x and y coordinates of the crossing points are the x and y solutions to the simultaneous equations. Okay, so those are things that we know from previous chapters. So if we put all that together, and we're looking at section 6.3, intersections of straight lines and circles, well, I know that a circle and a straight line can not intersect at all, can intersect at 2 points, or the straight line could be a tangent to the circle. Okay? Where are we going to get intersections of straight lines and circles? We'll take the equations and solve them simultaneously. Okay? I should put in a quick note here. A lot of people like to think of this, so if I take the first one as an example, that's equation 1, that's equation 2. When you dealt with looking at crossing points of functions, a lot of people are used to saying, well, I'll put them equal to each other. Now, you can't just put the left-hand side equal to the left-hand side, or the right-hand side equal to the right-hand side or something. What you're doing when you're putting two things equal to each other is you've got them in the form y equals this, and the second one is also in the form y equals something else, and you take the y from one equation and make it equal to the y from the other equation. You're actually substituting from the first equation into the second equation. Now, when you get a circle equation, I don't want to have to mess around with equation 2 and rearrange it and try and get y on its own somehow before I can substitute in from equation 1. So think of it as solving the equation simultaneously. So if I wanted to know where these two things crossed, I'd take y and I'd substitute. So I'd substitute from equation 1 into equation 2, and I'd get x squared plus x plus 5 minus 2 all squared equals 29, and I'd work from there. Okay, we know to need to solve that. Now, what we're going to get if we're solving an equation of a circle and a straight line together, you'll find that halfway through your simultaneous equations working out, you'll get a quadratic. And here is the quadratic for this example. Look, that is a quadratic in x now. And that quadratic can have 1, 2, or 0 solutions. If it has one solution, then we're in this position, aren't we? We've got the line and the circle. The line is a tangent to the circle. If we've got two solutions, we're in this position. The line and the circle, the line goes straight through the circle and hits the edge of the circle at 2 points. And if we've got 0, then the line, if this quadratic has got 0 solutions, then that line doesn't hit the circle at all. Okay? Now you can perhaps start imagining the sort of questions they're going to ask you. When do quadratic equations have no solutions? You're thinking back to your quadratics chapter and you're thinking, well, that's where I look at the discriminant. So now they might start asking you nasty questions about, here is an equation of a line, here is the equation of a circle. The circle, the line is a tangent to the circle, and then you're going to have to start trying to solve. You're going to end up with a quadratic halfway through the solutions, and that quadratic will have coefficients, and maybe the coefficients of the quadratic have a missing number in, right? So there's a k or an m or something that they've left in there, and you have to say, well, but I know that the line is a tangent to the circle, therefore I know that there is only one solution to this set of simultaneous equations, therefore I know there's only one solution to this quadratic, therefore I know the discriminant equals 0. So we have to, again, throw this together with everything we know from chapter 2, I think it is, the quadratics, and also the things that we know, I think, from chapter 3, the simultaneous equation stuff. Now, chapter 6 isn't that hard a chapter in terms of the new material, but by the time you get to the mixed exercise, as my Year 12 Further Maths group were telling me last week, mixed exercise 6 is hard work. There's an awful lot of it, and the questions aren't that easy. The reason the questions are difficult isn't because there's a load of new difficult maths in chapter 6. It's because chapter 6 is about taking a few new ideas, a few old ideas, and mixing those together with everything we've seen in chapters 1, 2, 3, 4, and 5. So we're using the graphs from chapter 5, the quadratics from chapter 2, the simultaneous equations from chapter 3. Maybe there's even a way of an examiner getting clever and throwing in some inequalities in there as well. Okay, so that's what happens a lot at A-level. The questions get difficult when they mix up a lot of ideas that we know. If you're finding that you get stuck, the answer is to go back and make sure you know each of those individual ideas first. If you don't know each of those individual ideas separately, if you're not comfortable on chapter 2, you're not going to be able to do chapter 6. Often what I find is I'm teaching people who are getting stuck on chapter 6 and just stay on chapter 6. You need to bite the bullet and say, right, actually, I never really understood chapter 2. Go back and do chapter 2, come back to chapter 6. Now that might mean you don't get chapter 6 sorted out for, I don't know, for the homework deadline. Maybe chapter 6 takes another 2 weeks because you have to go back and redo chapter 2 properly. But if you try and get away without redoing chapter 2 properly, you are never going to understand chapter 6. You cannot do chapter 6 without knowing about quadratics. You cannot do chapter 6 without understanding simultaneous equations and how to solve them graphically. So don't try, if you don't understand those earlier ideas, go back and sort those out. Now hopefully you've got a teacher who is going to be reasonable if you go and talk to them and say, look, I'm stuck, I can't do chapter 2 and 3, so I can't do chapter 6. They might be irritated that you should have been able to do chapter 2 and 3 by now because they set your deadlines and whatever, but that, you know, at the end of the day, they're going to understand that you have to be able to do chapter 2 and 3 first before you can do chapter 6. So talk to your teacher, find a way of getting some deadlines in for chapter 2 and then chapter 3 and then chapter 6, but you can't just bang your head against chapter 6 until you solve it. You have to make sure you've done the groundwork first of all. Okay, that's the end of section 6.3, and we'll carry on with 6.4 another time.